Welcome back to the deep dive. Today we are really opening the source code on a fundamental skill. We're diving into the very first steps, learning Python, and we're using this great beginner guide, Python 101, Lesson 1 First Steps, aimed at KS3 or Year 8 students, put together by Mr. Catalia. So if you've maybe been putting off learning to code, maybe it feels a bit abstract, or I don't know, too complex. Well, this deep dive, consider it your on-ramp. Our mission here is basically to give you those key insights, the stuff you really need, to move past just theory, get your workspace set up, and actually write, run, and even debug your very first bit of code. We want to give you the fastest path to doing something practical.
Absolutely. And we're really zeroing in on the crucial steps. We'll talk about why Python's a good place to start. We'll try to demystify that coding environment thing, walk you through the essential print function, how it works, the syntax. Then we'll tackle debugging because errors will happen. And really importantly, explore the difference between outputting text versus outputting numbers. That's kind of where the logic really starts to kick in.
Okay, let's jump right in then. Why Python? I mean, you see it everywhere, right? Web stuff, automation, AI. But if you're a beginner, wouldn't something maybe, I don't know, faster or even block coding, something more visual, be better?
Yeah, that's a really common question, and it gets right to Python's sweet spot. Sure, there are languages that execute faster once compiled, but Python, it's chosen because it's just so simple and readable. The syntax, the way you write it, it almost looks like, well, like English sentences in a way.
Yeah.
And that clarity, that simplicity, it means you spend less time fighting with semicolons or curly braces and more time thinking about the actual logic of what you want the computer to do. That's why it's huge and feels like AI and automation. You can try out complex ideas really quickly. It just makes that initial learning curve feel, well, a lot less steep than something like C++ or Java.
Right. Okay. So it lets you learn the thinking part, how to instruct a computer without getting totally swamped by grammar right off the bat. Let's dig into that idea, thinking like a computer. I mean, what is programming, really? It sounds kind of magical sometimes, but at its heart, we're just giving really, really clear instructions, aren't we?
Exactly that. Programming is, fundamentally, writing instructions a computer can understand and then, execute. It's the language we use to tell the machine what to do. And if you boil down what these instructions let us do, there are kind of two main buckets. First one is task automation. Think about repetitive stuff or complex tasks, sorting thousands of files maybe. Programming lets you automate that, makes things way more efficient.
I always think of it like a recipe, but for someone who takes everything literally, pathologically, literally, miss one tiny step, use the wrong word for an ingredient, and the whole thing just falls apart. Or you get something completely unexpected. That precision has to be spot on.
That precision is absolutely key. And that ties into the second big function, software creation. This is the stuff you see, right? Building websites, making apps, creating games, all of that needs those super specific instructions to work reliably and give you, the user, a good experience. It powers pretty much all the tech you use daily.
Okay, so Python's readable. We're writing super detailed instructions, automating or creating stuff. Let's get practical. Say I open my laptop, ready to code. What am I actually looking at? What are the three key tools in that coding environment?
Right. This is where we move from the idea to actually doing it, boosting your productivity. Getting your workspace right is, well, it's crucial. The source material highlights three main things you'll constantly be interacting with. First up, the code editor. This is your main writing space. And here's a useful tip. Technically, yeah, you could use something basic like Notepad, but modern editors, often called IDEs, integrated development environments, things like VS Code or PyCharm, they're much, much better.
Why is that? If I'm just starting, wouldn't a simple box be less confusing?
It's about the help they give you. A good IDE has syntax highlighting. It color codes different parts of your code functions look different from text strings, from variables. And that's not just pretty, it helps you instantly spot mistakes, like, oh wait, I missed a quote mark and now half my code is green. Using an IDE makes finding those little errors so much faster for a beginner. It really speeds things up. Okay, second tool, the run button function. Or whatever executes your code. This takes those instructions you wrote and actually makes the computer do them. Basically, it runs your code so you can test it right away. And testing quickly, that's vital when you're learning.
And number 3 is where you see if it worked or where the error messages pop up.
Exactly. That's the console output. This is where the program talks back. It shows the results if your code ran successfully. But just as importantly, it's where you see error messages if something went wrong. The console is also often part of what's called a REPL read evil print loop. You type code, it runs it, prints the result. It's very interactive. which is a big part of Python.
Gotcha. So understanding that flow type in the editor, hit run, see results or errors in the console, that whole loop is the basic workflow. All right, now the really fun bit, everyone starts here. The single most essential function when you're brand new, print. Let's make it concrete. We want our program to just say hello to the world or to the user.
Okay, the print function, its job is simple. Display text or data in that console we just talked about. It's how your program communicates outwards. So to get that classic hello world message, you type print, hello world. And that one little line, it introduces two really critical syntax rules you'll use constantly in Python.
Rule 1, the parentheses. Why are they essential? Can't I just type print hello world?
Ah, good question. In older versions of Python you could, but not anymore. And for good reason. The parentheses clearly define what belongs to the function. They tell Python, okay, everything inside these brackets, that's the stuff the print function needs to work with. Now, hey, if you forget them, or maybe mismatch them, like forget the closing one, the computer just gets confused. It doesn't know what data you wanted to print. It's like telling someone to pick up, but not telling them what to pick up.
Okay, makes sense. And rule 2, the one I bet trips people up all the time.
Yeah.
The quotation marks.
Yeah.
Why do I need those? Why not just print hello world?
Right. The quotes are vital. They tell Python about the type of data. Those quotes signal that what's inside is text, what programmers call a string. When Python sees quotes, it thinks, okay, don't try to execute this or figure it out. Just display these exact characters. Okay, if you left the quotes out from hello world, Python would think hello and world were maybe variable names or commands it should know, and it would probably give you an error. It's crucial for telling the computer this is just data to show.
That difference text is just passive characters versus something the computer tries to understand. That seems huge. So if you're listening, try it. Use that exact structure. Print, parentheses, quotes. Print your name or a favorite quote. Seeing your words pop up in the console. That's when you know you've got the basic syntax down. It's a great feeling. Okay, but speaking of syntax, errors, let's be real, they happen all the time. You don't get good at coding by never making mistakes, right? You get good by figuring out how to fix them. Debugging isn't failure, it's just part of the process. The sources point out 2 really common traps for beginners with this simple print function.
Oh, absolutely. Most of the early frustration comes from these tiny mistakes in structure. The computer sees them as, like, showstoppers. So, trap number 1, case sensitivity. Python cares a lot about whether letters are uppercase or lowercase. The function name print has to be all lowercase. If you type print with a capital P or print all caps, Python doesn't know what that is. It'll throw a name error, basically saying, I have no command name print.
Wow, okay. That feels like it would be super frustrating when you're starting. Such a tiny detail.
It can be, but that strictness is actually what helps the computer be unambiguous. It knows exactly what print means, and print means nothing to it. The second big trap, we kind of touched on it, goes back to structure. Parentheses, use, forgetting that closing parenthesis. Or maybe using a square bracket where you needed a round one. State, that's going to give you a syntax error.
Okay, so if I see syntax error on my screen, what's the computer really trying to tell me?
It's essentially saying, the way you wrote this breaks the basic grammar rules of Python. I can't even figure out what instruction you're trying to give me because the structure is wrong. So, getting used to spotting those specific errors, name error likely means casing, syntax error likely means punctuation, like parentheses or quotes that builds confidence fast. You start seeing the error message not as just fail, but as a clue. Syntax error. Let me check my brackets and quotes. And honestly, even experienced programmers forget a closing bracket sometimes. It happens to everyone. It's almost a rite of passage. 9 times out of 10, a syntax error means you missed some punctuation somewhere nearby.
That's actually really good to hear. Knowing errors are normal and learning to read the clues, that's as important as writing the code itself. Let's shift to the final, maybe the most important piece of basic logic here. Understanding the difference between the 2 main kinds of output, text versus numbers. Getting this right seems critical for making your program do what you actually want it to do.
Yes, this gets to the heart of data types. When you tell Python to print something, it needs to know how to treat that something. Is it just characters to display? Or is it a value it should maybe calculate? So like we said, string output, that's text, happens when you print with quotes. And print 4 plus 4. The quotes tell Python, treat this whole thing 4 plus 4 as just a sequence of characters. So it will display exactly that, the character 4, the character plus the character. It's just text.
But if I want the computer to do the math, actually calculate 4 plus 4, I need to drop the quotes.
Exactly. That's numeric output. Printing without quotes tells Python to evaluate whatever is inside the parentheses. So if you type print 4 plus 4, no quotes, Python sees the numbers, sees the plus sign operator, performs the addition, and outputs the result of that calculation, which is the number 8. And you can do basic math right inside print like that. Addition, subtraction, multiplication, division. It calculates and shows the answer immediately.
Okay, that seems straightforward, but I can easily see how mixing that up could cause chaos. Like, what happens if you try to, I don't know, add things that are different types? Or add 2 strings. You mentioned print 4 plus 4 just shows the text. What about print 2 plus 2?
Ah, you're hitting on a really key concept there. If you try print 2 plus 2, Python sees the quotes, knows their strings, text. And the plus operator, when used with strings, doesn't mean arithmetic addition. It means concatenation, which is a fancy word for stick them together. Brrr. So print 2 plus 2 outputs the string 2, 2, not the number 4. And this is why understanding data types is so critical, even at the very beginning. Imagine you're building something that handles money. If you accidentally treat a dollar amount as a string because maybe you read it from a text box, and then you try to add it to another amount using plus allers, you'll get concatenation. $10 plus $5 becomes $10 not calculation. $10 plus $5, $15. Your program's logic completely breaks. So knowing quotes mean this is text, don't calculate it, is fundamental for correct behavior.
Wow, okay. That really clicks. That simple choice quotes or no quotes totally changes what the computer does, calculation versus just displaying characters. So let's wrap this up. What have we given you, the listener, today? We've looked at the fundamentals, why Python's readability is great for starting out. How to set up your coding space, the editor with its helpful highlighting, the run button, the console for output and errors. We mastered the basic print function, paying close attention to parentheses and those all-important quotes. We talked about common errors, case sensitivity causing name error, punctuation issues causing syntax error, and how debugging is a skill, not a failure. And critically, we just explored how to control output, using quotes for strings, text, versus no quotes for numbers, calculations. These ideas, they're the bedrock. They're essential for writing effective code and, honestly, for feeling productive right away.
Yeah, and if we pull that thread just a little further, we've established that Python needs to know the type of data. Text needs quotes. That's a string. Numbers need no quotes if you want them evaluated. So here's that final thought to chew on. Building on that concatenation idea. You know how to print text. Print the result instead. You know how to print a calculations result. Print 4 plus 4. How do you combine them cleanly in one go? How do you tell Python, print this text, then print the calculated number right after? Like the result is 8. Getting that combination right. It usually involves converting the number to a string first or using special formatting and figuring that out. That's really the bridge to handling more dynamic, more complex output in pretty much any programming language.
A perfect challenge to take into your next coding session. Thanks for diving deep with us today.